Hi, I'm Kathy Levinger. In this lesson, we're going to solve quadratic equations using the quadratic formula. Let's start by reviewing the formula. For a quadratic equation in standard form, which would look like ax squared plus bx plus c equals 0, the solutions can be obtained from the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. Well, let's try out the formula and solve some equations. We want to start by using the quadratic formula to solve for x in the equation x squared minus 5x plus 6 equals 0. A in the formula is the coefficient of x squared, which is 1. B is the coefficient of x, which is negative 5. And c is the constant, which is 6. Now putting those into the quadratic formula, I'll write down x equals negative 5 plus or minus the square root of negative 5 squared minus 4 times 1 times 6, all of that divided by 2 times 1. Continuing, x is equal to negative 5 is 5 plus or minus the square root of negative 5 squared is 25 minus 4 times 1 times 6 is 24 divided by 2. And I'll continue. X is 5 plus or minus the square root of 1 divided by 2, which is 5 plus or minus 1 divided by 2. I need to go a little bit further and get the exact values of x in this problem by breaking this into 5 plus 1 divided by 2, which is 6 divided by 2, which is 3, and 5 minus 1 divided by 2, which is 4 divided by 2, or 2. So the two solutions to the quadratic equation are 3 and 2. Let's try another. This time we want to use the quadratic formula to solve for exact and approximate solutions to the equation 4x squared equals negative 5x plus 8. Well, before we can apply the quadratic formula, we have to have standard form. We get standard form by adding 5x and subtracting 8 from both sides and setting the equation equal to 0. In the quadratic formula, a is 4, b is 5, c is negative 8. Substituting those values in, x is equal to negative 5 plus or minus the square root of 5 squared minus 4 times 4 times negative 8 divided by 2 times 4. Continuing, x is equal to negative 5 plus or minus the square root of 25, 5 squared, minus, now I need to figure out, with the help of a calculator, 16 times negative 8, which is negative 128, and divide that by 8. Continuing, I want to simplify what's in the radical, and I then have x equals negative 5 plus or minus the square root of. This ends up being 25 plus 128, which is 153 divided by 8. 153 is a prime number, and so these two numbers are exact solutions. Negative 5 plus square root 153, negative 5 minus square root 153. Actually, let me think about 153 for a minute. 153 might be divisible by 9, so I shouldn't jump to conclusions. Let's try that. 153 divided by 9 is 17, so I'm wrong. It's not a prime number. We need to continue to simplify x equals negative 5 plus or minus square root of 9 times 17 over 8, which is negative 5 plus or minus. The square root of 9 is 3, but there is no exact square root of 17. And now we are at a point where we have simplified exact answers. These were exact, but now they're simplified. To get approximate solutions, we're going to get decimals for each of these two answers. But first I'm going to write them on another sheet of paper. We have negative 5 plus or minus 3 square roots of 17 over 8. This is two different numbers, and we're going to enter into our calculator negative 5 plus 3 square roots of 17 over 8, and negative 5 minus 3 square roots of 17 over 8. So let's grab a calculator, and I'll show you how you could enter these and conveniently get the solutions. We need to start with an open parentheses for the numerator and put negative 5 plus 3 times the square root of 17, close parentheses for the square root, close parentheses for the numerator, then divide by 8 and push enter, and that solution is 0.921194 and so forth. To get the other solution, which is negative 5 minus 3 square roots of 17, push second and the enter button on your calculator, and it pulls back the previous entry into active mode, and you can use your arrow key to highlight the plus sign and make it a minus sign and push enter, and the other solution is negative 2.17. So we have solutions, approximate solutions, 0.92 and negative 2.17 that we can write in. The first here is approximately 0.92. The second is negative 2.17. Well, let's try another example. Again, we want to use the quadratic formula to solve for exact and approximate solutions. We have t squared minus 14t plus 49 equals 0. This is already in standard form. A is 1, B is negative 14, and C is 49. Substituting into the formula, I'll have t equals, because t is the variable, negative negative 14 plus or minus the square root of negative 14 squared minus 4 times 1 times 49 divided by 2 times 1. Simplifying, t equals 14 plus or minus the square root of 14 squared, which is 196, minus 4 times 49, which is also 196, but we haven't made a mistake, divided by 2. And so this is t equals 14 plus or minus the square root of 0 over 2. The square root of 0 is 0, so we only get one solution, 14 over 2, which is 7, and that is the solution to the quadratic equation. Let's try another example. We want to use the quadratic formula to solve for exact and approximate solutions to 5t squared plus 2t equals negative 7. Well, this one needs to be put in standard form, and I'll do so by adding 7. 5t squared plus 2t plus 7 equals 0. A is 5, B is 2, C is 7. Substituting into the formula, I'll have t equals negative 2 plus or minus the square root of 2 squared minus 4 times 5 times 7 divided by 2 times 5. Continuing, t equals negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 5 is 20, times 7 is 140 over 10. And continuing another step, I have t equals -2 plus or minus the square root of 4 minus 140 is -136 divided by 10. Now the square root of a negative is not real. At this point we'll stop and say non-real solutions to the quadratic equation. There's one particular bit of the quadratic formula that's of importance, and it's called the discriminant. The discriminant of the quadratic formula is b squared minus 4ac. This is exactly the quantity that is inside the radical in the formula. If this discriminant is positive, you know there will be two real solutions to the quadratic equation. If the discriminant is 0, there's only one solution, and we saw an example like that to the quadratic equation. If the discriminant is negative, there are no real solutions to the quadratic equation. Let's try out the discriminant. We want to find the discriminant for each quadratic equation below and use it to determine how many real solutions the equation has. The discriminant is b squared minus 4ac. In this equation, the first equation, a is 3, b is 4, c is -1. The discriminant will be 4 squared minus 4 times 3 times -1. Simplifying, that's 16 minus -12, or 28. Since that's positive, whoops, forgot the I, there will be two real solutions to the quadratic equation. Well, our next quadratic equation needs to be put in standard form before we can find the discriminant. Adding 1 to each side, it is the equation x squared plus x plus 1 equals 0. In this case, in this equation, a is 1, b is 1, and c is 1. Putting those into the discriminant, I get b squared minus 4 times a times c, which is 1 minus 4, or -3. This is the discriminant. The discriminant is negative, which means there are no real solutions to the quadratic equation. Well, in this section we've practiced with the quadratic formula. Be sure to work some exercises from your book for practice.